Okay, good morning everybody, or at least it's morning for us if you're from somewhere else. Welcome to Red Badger's first ever webinar, part of a series that we're calling Be Bold with Tech. So just to explain quickly how this works, we're going to have a quick discussion about a few technologies like React and Docker and things like that. And we'll be taking questions at the end, so if you want to submit your questions directly to the GoToWebinar system, they'll all get saved and then we'll pick them up at the end. But first of all, we're going to be talking about Docker, React, and Node. And we should think about why should we be talking about this, right? We at Red Badger have a bit of experience with these technologies. We've been using them for quite a long time. So Docker for sort of 2 years, Node for about 6, React for over 3. Since it was pretty much first came out, we used it on a project. And we've been using these technologies to push our clients' technologies sort of landscape forward and solve hard problems for them. So Red Badger, in general, is a digital consulting agency. We are based in Old Street, and we're all about solving hard problems for our clients and then pushing them into the sort of latest technology that's going to help them drive forward in the future. So joining me on my left are my two friends, Greg Stewart, CTO of Red Badger, and another Stuart Harris, with his new title of Chief Scientist of Red Badger. Both of these guys are, their job is to push our technology landscape forward, keep discovering new technologies, and help to solve these hard problems that our clients encounter. Right? So we're going to start talking about, we're going to talk about all three of these. We're going to talk about Node and React to start off with as a pairing. So Greg, you're going to kick us off with this, right? Give us a bit of an overview of what these two things are.
I am, yes. Hi. Good morning, everyone. So let's start with Node. Node was written by a chap called Ryan Dahl back in 2009. And his goal was to get JavaScript to run outside of the browser. And in order to do that, he took Google's V8 engine, wrapped it in an event loop, and sort of created a set of APIs that sort of managed input-output operations. This led to a tool that's perfectly suited for building high availability, highly scalable websites. So that's amazing. And I think you mentioned that we started using it back in 2011. So. Yeah, very early on in its life cycle. And then on the React side of things, well, that was written by Facebook. They built it in 2011 to sort of solve performance problems they were experiencing with their newsfeed. So it concerned itself specifically with the view layer of the stack, if you think of the MVC kind of paradigm. It was open sourced back in 2013. And that's basically when we started adopting it. The first project we used was on Haller, which was a sort of pro bono project that we did, and then we started using it for all of our clients, from Tesco through to Lloyds, and to what we're doing today.
Excellent. So that's a bit of an overview, but there's obviously many server-side languages, frameworks out there. Why on earth should we be using Node?
So Node's a bit different that it's sort of event-driven and has a non-IO blocking sort of paradigm, and as already mentioned, it lends itself to building really sort of highly scalable kind of websites. The other thing to consider really is that JavaScript is a really popular language, sort of not far behind Java and C# and others, which means that in terms of finding people that know JavaScript is sort of a relatively easy task to do these days. And because the developers can work on both the front and the back end, so the domain knowledge is shared across both sides of the stack. And the other thing really to consider there is, it's got sort of wide enterprise or corporate adoption, so you can find it used by companies such as Netflix, eBay, PayPal, Walmart, LinkedIn, so the list is really endless. But it's also backed by a foundation from IBM, Microsoft, the Linux Foundation as well as Joint.
Excellent. So what about React? I mean, equally there's many client-side frameworks out there. What does React give us?
So React, there's lots to say, lots to say really, but let's focus on a few points, I guess. Stuff that always really sort of interests me is being able to build sort of small components, and React is perfectly tailored for that, so it makes you think of your UI in terms of components, and these are small, they're reusable, and they're composable. And that's sort of something that a lot of companies strive for, to have these sort of particularly reusable aspects, and building up component libraries that you can use across your applications. Because these components are also functions, there's an incredibly powerful paradigm there where you can think of your view as a projection of your state. So essentially, it's a transformation that goes on. And then because they're functions, they're really, really highly testable, and that's something that I care deeply about. You can really apply sort of test-driven kind of paradigms to it. And that is really good when you think at the unit level, whereas previously you used to test your UIs through the browser. So big, expensive, very brittle sort of end-to-end tests, and now you can really bring it down and have a really sort of small, sharp sort of feedback loop there. The other thing that you might want to sort of think why it's amazing to use React is the React Native aspect. So you learn React once, and now not only can you build sort of your web UIs, you can also transfer that knowledge onto building iOS and Android kind of apps. Another really interesting paradigm that sort of React introduced is shifting us away from the sort of data binding, two-way binding, data flow kind of approach to a unidirectional kind of flow. And we can talk about that a little bit later on maybe. But it's got wide adoption now, so if you on the slide you can see there's a lot of sort of big companies that are sort of embracing that sort of technology as well, and it's got quite a large sort of community support as well.
Yeah, and a lot of giant corporations on that list on the slide, and also very sort of innovative corporations, right? It's got a pretty good betting from many people. But we've grouped these two technologies together, which might confuse some people as to why.
Yeah.
What is the pairing of these two technologies? What does that give us?
Yeah, why is that so bold, really? Well, if you move on to the next slide, we can actually answer the big sort of bang, the isomorphic kind of approach. Yeah. So some people call it isomorphic, some call it universal, but I mean, effectively what this means is you're writing your JavaScript once, and it runs both on the client side and on the server side, which is really powerful. It's powerful because not only is it the same code, but it really allows us to deliver the best kind of user experience possible. If you consider things like faster sort of loading times in the old world of single-page applications, the index file will be sent to the browser, then it would fetch all the assets and start parsing the JavaScript and then start rendering it sort of quite slow. If you think that you can now do an initial render of the entire page using that same stack and send that all down to the browser, that gives you a much faster loading time. And also, we can do then is we can consider turning off JavaScript on the browser side, particularly for devices that are maybe underpowered and not fully featured, so feature phones and that kind of stuff, or maybe even for your TV set-top boxes, wherever JavaScript runs these days, which is, as I said, everywhere. So that allows us, of course, to then reach a much wider audience of users with fewer kind of workarounds, which is really amazing. And this is something that we've applied for some of our clients. So we've done work in the financial services area, but I think the one where it really sort of shines through was our experience at Tesco, which I know you were involved in quite a bit, and where we built out the groceries journey first internationally. So particularly aiming at markets where there were not such fully powered devices and feature phones. So and we built that there first, and then moved to the UK markets there and leveraged all of that sort of isomorphic
We even found on some of the slower phones, the server-side journey was just better.
Yeah.
Right? It's a very powerful tool.
And better usually translates to more click-throughs and kind of conversion and that kind of stuff.
I guess the opposite is true as well, is that you could turn the server rendering off if your servers were overloaded and just have client-side rendering.
Absolutely.
Feature flag.
It's in both places, so you can do both.
Save a bit of cash.
Yeah.
Okay, so especially in the world of front-end technologies, it all seem to be like sports teams at the moment. Everyone's cheering for one or the other. They've got their cheerleaders on Twitter. But I feel like you can only really know a technology and know whether it's relevant for you when you know the limits of it. So why shouldn't we use these two technologies?
I mean, I guess any kind of choice that you make in technology is all about sort of trade-offs. And if we start with React, maybe one of the things that often gets pointed at is that it's considered only with the view, so it's not like a kitchen sink approach. It's just a library for the view. Whereas some folks prefer to have a fully fledged framework like Angular. So I think that's actually a good thing personally, because I like small, sharp tools that do one job and one job very, very well. So that unique kind of philosophy. But your mileage may vary in that kind of space. And we spoke about this the other day. If you look at the spectrum of the types of applications that you can develop, if you're looking at something small and simple, then maybe using React is a bit of overkill. And at the other end of the spectrum, if you're building like a highly interactive game, then quite possibly you'll be pushing the performance limits of React in that space too. When it comes to Node, why would you not be using Node? Well, Node is single-threaded, so it doesn't inherently make use of all the cores that your CPUs have these days. Of course, you can use things like cluster or other kind of tools to sort of leverage that, but there is no built-in sort of management of those threads there. That then also means that anything that's sort of CPU-intensive, highly computational, that starts sort of hurting the performance of Node there. Another criticism I've seen quite a few times, and there's maybe more to do with the maturity of Node in the JavaScript landscape on the server side, is that there's not much in the space for sort of simple CRUD-like applications. So I think Rails, Django, those kind of frameworks, they're not really there yet. But again, it's choosing the right tool for the job.
Absolutely. Yeah, that's a good summary. So lots of people not watching might have been looking at these bits of tech for ages. They might have been dying to use it. They might be convinced just from today. How on earth do you convince your boss that this is a good call? What's your boss getting out of all of this?
What's your boss getting out of this? So, I mean, as a consultancy, we very often try and introduce new technologies to clients. And one of the things that we always hear is like, well, how would I hire for this particular framework, language, tool? Well, with JavaScript and React, well, it's quite simple. It's, as I said, one of the most popular languages out there. So finding developers is quite easy. You don't have to pay for them, but you can still find them. The community is extremely vibrant, and the ecosystem is thriving as well. Some say it's moving too quick and too fast, but that's a good problem to have, right? We touched on the Node and React being really optimized around performance. So if your use case is for a particular area, then you could leverage that. We spoke a little bit about developer productivity and happiness. These are great tools for that as well. Specifics for, let's say, what is Node really good for? JSON APIs it's really strong for. So that fits perfectly well in with the sort of RESTful sort of paradigm that's been dominating our back-end kind of approaches. But also, if you're considering like sort of streaming data-based architectures, then Node is well suited for that too. The other thing, maybe with React, to consider, well, I mentioned the bidirectional versus unidirectional kind of flow, so that really sort of reduces the amount of sort of bugs that you come across and trying to sort of reason about the state of your application as it's running. So that's really kind of a good thing there. And I think one thing that is, I mentioned beforehand, I think components being functions, being able to test drive those is so powerful, and it reduces the load on your end-to-end kind of tests. And then, what I think is great about React, for example, is the fact that Facebook dog foods it, so it is something that they use straight away in their application. So what you see, what the user gets to play with, what the community gets to play with, is something that they've been using internally for a while as well, which is not necessarily true of other frameworks such as Angular, right? So Google doesn't use that.
And React 16 was on Messenger.com for months before it came out, all that kind of stuff.
Exactly.
It's well tested already by the time it comes out.
And it's out now.
And it's out as of yes. As well as technical suitability, that sort of suitability for the team productivity can't be understated.
Yeah, and you might be worried as well in terms of what's corporate support and how does it exist if you're in a large organization, and there's companies like Joint that do provide that, and knowing that all these large organizations like Walmart and PayPal are using it should give even smaller orgs a bit of comfort in that space.
Absolutely. Okay, so Stu, on to you. On to our next topic of Docker.
Yeah.
Docker's become almost a buzzword at this point that people like to float around. What is Docker? Tell me about that.
Yeah, it's a good question. Hello. It's for me, I think the most important thing about Docker is that it's a way to package your applications or your services in a microservice as well, with all of their dependencies using containers in so you can deploy them in a standardized way. So it's like a standard shape box that you can put your stuff into, so that where you're deploying to, the platform you're deploying to, and everything doesn't have to worry about what's actually inside the containers at all. And of course you can put anything inside the containers. So that's really good because it leads to polyglot architectures, which are a good thing. So that allows you to basically choose the right tool for the job and package that up inside the container, and then to the rest of the world doesn't matter what it is, which is a great thing. I suppose the obligatory metaphor with shipping containers is valuable in the sense that standard size and shape box allowed us to ship goods all over the world in a really efficient manner, in a way that we'd never seen before, and completely changed the world. And this is exactly the same thing with software. You can just basically put your stuff inside a box and ship it. One of the great things about it for me is that it allows us to embrace this concept of immutable infrastructure as code. Containers are immutable. You build them once and you never change them. You only create and destroy them. So if you want to make it better, you make it better in code. That code evolves and create new containers and run those instead. So that's a massively important thing, because you'd never go inside a container and change stuff manually. That gives us high confidence that what we're running is exactly what we built, and allows us to, and what we tested as well, of course, and allows us to reliably repeat deployments as many times as we want to, knowing that we've got exactly what was built and tested. Yeah, and those are the main characteristics of it, I think.
So some of the things you described, I think people could be easily mistaken for thinking of virtualization, right? Like virtual machines, you can build those up, load it onto a server in almost a similar way. What's the difference between virtualization and containerization?
Yeah, absolutely. So, I mean, you could use virtual machines in exactly the same way, but they're just heavier, right? I mean, you can do immutable infrastructure with code with virtual machines as well. But containers are much more lightweight. They're process-based, so they're basically processes that run inside the virtual machine, where each process is isolated from the rest of the machine using C groups and LXC containers and copy and write file systems. So there's you create them using a Docker file, and the Docker file describes all the layers that are built upon in order to create an overall image. So the base layer may well be an operating system, and then after that you may put the dependencies in a sort of build environment or whatever, and then you might build your application and run all the unit tests, and then copy the artifacts into a really lightweight image using the new Docker multi-stage build, and that allows you to create basically a set of layers which describe the differences from the layer below. So the first layer is quite big usually, and then the other layers are just incremental changes on top of that. That allows the resulting image is really quick to start up, because really you just have to basically translate those layers and put it inside a process and isolate it from the rest of the system. So very lightweight basically.
And building is quick. All those layers are cacheable.
Yeah, exactly.
So are there any alternatives to Docker that give the same kind of feature set, these advantages?
So there are, but Docker kind of is taking over in a sense. CoreOS has a container technology called Rocket, and you could also use vanilla LXC containers. But the important thing is that that Docker kind of adds a layer of value over those containers, which allow you to sort of manage them and work with them much more easily. But they're standardizing all of these things. So Docker started the Moby project, and that is an attempt to take all the component parts of the Docker subsystem and standardise them for broad acceptance. So there's the container daemon was donated to the Cloud Native Computing Forum Foundation earlier this year, and runC, which is the container runtime, last year to the Linux Foundation. So these are attempts to be able to basically standardise how containers work, what they look like, the standard size and shape, so that we don't have like multiple divergent technologies that compete on each other. And that's actually working very well. So a lot of the alternatives, such as Kubernetes for container management, such as Kubernetes, which is Google's infrastructure effectively for everyone else, with value add like from OpenShift and CoreOS using with TakeTime. There's also Mesos with Mesosphere Marathon, which is container scheduling, and Cloud Foundry with PCF and IBM's Bluemix, adding layers of value on top. But they're all really about scheduling containers, and the underlying technology is Docker containers, and that's pretty standard now. So.
Yeah, a pretty advanced tool set.
Yeah.
So you mentioned scheduling tools like Kubernetes. There's a few out there, and Docker Swarm is kind of coming into the mix now. From the first party.
Yeah.
What's the kind of difference between all of these scheduling tools? How can we choose between them?
So it's a really good question, because there's probably not a lot to choose between them, right? So Kubernetes is becoming very popular. It's possibly a year older than Docker in Swarm mode. What Docker did with that, there used to be a separate thing called called Docker Swarm, which is a separate thing from the Docker engine, and then last summer they brought it into the Docker engine and called it Docker in Swarm mode. So now a Docker engine can be running with just local containers, or it can be running in Swarm mode, so it can participate in a cluster. And Kubernetes is in exactly the same space. I think it probably has a slightly higher cognitive load. There's more bits to it. But I think it's perceived possibly as being a little bit more sort of industry scale or whatever. But I think that's largely just a perception, and I think Docker in Swarm mode is actually getting to be really, really, really good now. I think Docker have done a really, really good job of taking all of the bits that are important about a platform, things like container scheduling and zero downtime deployments and secrets management and service discovery and all that sort of stuff, and actually simplifying them and making them into a really, really easy to use thing, which is so easy to use that even a cross-functional team can manage their own environments and build and create environments that they can deploy to, and they can manage them even in production quite simply with a small two-pizza size team. PCF, so great technology. It's a slightly higher level of abstraction in the sense that you just basically give it your code and a manifest, and it sort of kind of creates the container for you. In my head, I think this is missing the point a little bit, in the sense that it kind of breaks the immutable infrastructure as code paradigm, where you sort of like build a container and then run that, test it, and it goes through all the environments, and that's what ends up in production if your confidence level is high that there's no defects in it. Whereas with PCF, it get built for you, multiplies. I mean, it's a semantic difference, but yeah, I mean, they're all great.
Yeah, you briefly mentioned that sort of testing confidence. Like, it seems like a core concept of the containerization, right? That you can test it in one place,
Yes.
and that container travels through, and it's the same in every environment. If you're building it over and over again, that's not so true.
No longer the whole, it works on my machine, right?
Yeah. So, easy excuse. So I think there's a lot of questions still. Docker's changing a lot at the moment. It's developing. Is it stable? And there's a lot of questions over the security of containers.
Yeah.
Is it stable and secure enough for most people?
It's getting there. I actually think it is now. I think it's when things move quite fast, it does introduce a little bit of instability, and there's been a few examples of that over the last year or so. But now I think it's really solidifying up and actually stabilising down quite well. there's also Docker also provided Docker Enterprise Edition on top, which has got Docker Trusted Registry and like secure image delivery and a whole bunch of enterprise features, which improve the confidence that enterprises have in the security of it. From the security perspective, actually, it's worth mentioning that with Docker multi-stage builds, which we talked about earlier briefly, it's possible to create really tiny images that run in production. So there's nothing inside the container that your application doesn't need. So there's no daemons or whatever, SSH daemons or FTP daemons or whatever it is, that would increase the attack surface. So there are very few opportunities for attackers to because there's very little running in there apart from what's absolutely needed. And actually your application isn't going to be running in as root inside the container, or it shouldn't be running as root inside the container. And actually they're very short-lived often as well, because when they're being scheduled across multiple VMs in a cluster, they may be moved around a bit, and if you're doing continuous deployment, then they're changing all the time, so they're actually very short-lived. So the opportunities for an attacker to get in there and do some damage. The other massively important thing is because they're immutable infrastructure as code, and they're not designed to allow humans inside them. There's no way of there's very little opportunity for an attacker to get in. So I think actually they're on the stability side, they're getting it's there. Mileage may vary, but I think right now it's stable enough to use in production. And the security aspect, people worry about the security of containers, but actually I think they're overall more secure than virtual machines.
Small attack vector, and even if somebody got in there, you can't do very much.
Yeah.
So all of this sort of feels like maybe developer tooling. I mean, again, we mentioned testing confidence and stuff like that. We certainly believe that this can really transform an organization, right? Like, how can this transform the way that people work?
So I think personally, the most transformative aspect of it is that it allows us to build a continuous deployment into production pipeline really very, very easily. So we all know about continuous integration and continuous delivery potentially, but continuous deployment is where there's no human gate. So every single commit to master, every merge of every pull request effectively will end up in production, providing the confidence level is high enough from all of the automated testing that's going on inside. So we talked earlier about how the unit tests run inside the container, and then the extra testing from outside, but at each stage automating this approach. I believe that teams that are doing continuous deployment into production are at least twice as productive, and probably more than teams that aren't. So we can the whole transformation aspect of it is it allows us to build these small platforms that can participate in a continuous deployment pipeline that allows us to get stuff into the hands of the customers and actually get them value really, really quickly. And that's massive for organizations, especially big enterprises. The other aspect as well is that it allows us to break down the monolith. So if we've got a legacy system, because you can put anything inside a container, you can put your whole legacy system inside the container, and then at least it's participating in this new continuous deployment pipeline, and then you can break bits off into their own containers and build a microservices architecture around it.
Yeah.
That's massively transformative.
All right, thank you both. So we'll take any questions from the viewers. We don't have a huge amount of time for questions, but we'll take them if we can. Or we give people a bit of time to submit questions if they have any. You mentioned earlier, Stu, about we should tie this back to the title, Be Bold. What makes these things bold for a business, and why is it so important to be bold?
Yeah, I mean, it's a good question, isn't it? But I think these are the things that we've been talking about today are not really new. React's been around for 4 years, Docker for 2 or 3, and even though Docker has changed a lot, I think the industry is settling on ways of building software and deploying it and getting it into production quickly, and these are examples of that. There's no point in hanging around. Like in large enterprises, feeling the heat of that, but it's just warming up gradually, and those frogs are going to die before they get to a high temperature. And basically, we need to just do it right.
Yeah. So we've got a question from John Sharrett. I think I recognise that name. Do you think that Kubernetes has more appeal as a recommendation for larger companies now that AWS, Oracle, Microsoft, VMware, and Pivotal join the Cloud Native Computing Foundation and are supporting?
So I think
Kubernetes
is great technology. Right? So one of our largest clients that we're working with is using it as well, and I think it's the concepts around it that are important to me. So the ability to be able to manage and schedule containers in this way, in a sort of cloud provider agnostic way. So because these just run on VMs, they can run in any provider, and rather than using the cloud native tools like ECS and GKE, I think those, there's a bit of vendor lock-in and tie into those things, and actually we can build these things really quickly using immutable infrastructure as code, stamp them out, and they're all production identical, and cloud provider agnostic. You can run them anywhere, including on a laptop or on-premise. That gives lots of flexibility. So, but actually, whether it's Docker in swarm mode or Kubernetes, those are really the front runners. And
certainly doesn't make Kubernetes any less attractive.
No.
But again, it's about choosing the right tool for the job, right? I mean, you mentioned that Docker and Swarm mode provides a whole bunch of other features out of the box as well that you might want to leverage straight away. So whether it's secret management, that kind of stuff. Because Kubernetes doesn't do that out of the box, right? So it's a tool for a specific problem it's trying to solve.
It's definitely easier to get started with Docker and Swarm mode than Kubernetes. It's more complex, more moving parts.
Yeah, at least there's that tool, Minikube, for Kubernetes, which was a godsend last time I looked at it, because otherwise it's really hard. All right, thank you, John. We probably don't have a huge amount of time for more questions, so if anybody has questions in the future, please contact these two. So you can see on the slide at _Greg_Stewart_, or Stuart Harris. Tweet these guys, or if you've got any other, if you've got any questions that you want to email, you can email us at bebold@red-badger.com, and we'll be more than happy to answer them. So until then, we've dived into a bit about the pairing of React and Node and how powerful that is. And we've dived into the power of Docker, containerization, the testing confidence that can give you. We really believe that these three technologies are intensely important for this kind of, be bold, pushing technology forward in a certain company, right? Like, we picked these for a reason. Like, these are our most important ones.
And we've used them with great success in our clients. So
yes.
To be able to turn around projects very, very quickly using them, so it's equally important to reflect on that.
Yeah, absolutely. So, well, thank you very much for listening. If you enjoyed this, we'll do even more of them. So, again, email us at bebold@redbadger.com. Tell us if you liked it. And let us know if it was good and you'd like to know more, and even suggest topics for us to talk about. So until then, thank you very much. We'll see you next time.
Thank you.